Alright, last question on the Organic 2021 topic test. So we're starting off with our distillation and reflux question, which is one that you can expect to come across. And this one starts off by asking you to name the process used for each one of these. So you don't even need to worry about what they're doing in this case, you just need to look at the setup. So this is our reflux, it's vertically set up, and this is our distillation. Beautiful. Compare and contrast the advantage of including each of these processes in the procedure for carrying out the oxidation of a primary alcohol using ethanol with acidified potassium dichromate, and identify the products that would form using each of these procedures. Right, so let's start with reflux, and I'm going to use my blue pen for reflux. So when we're answering a question on reflux, we're going to define what it is for and say how it works, and then we'll relate it back to the question. So reflux is to speed up the rate of a reaction. I'm not going to write this all out, it will be here forever. Speed up the rate by using heat, but without losing any volatile products. Okay, so if you heat things up, then you run the risk of boiling off some of your liquids into gases, and whether they're reactants or products, you don't want to lose them presumably, because if they're reactants, you want to react more, and if they are products, you obviously are trying to make them. So that's what it is, why we do it, how do we do it. So the key here is that we put our alcohol and our dichromate, which is a beautiful orange colour, into this thing here, and then we apply the heat. Turn that on. Oh, I wanted red there. Okay, and then these two start to react. Oh, sorry team, I've moved that as well. These two start to react, and then when we make products and they turn into a gas and go up the tube, then the cold water that is continuously cycling through the outside compartment will ensure that the temperature drops and that substance condenses back into a liquid and goes back down into the container to continue reacting. So that shouldn't be the tricky bit. The how should be easy. Just go back to your notes and copy that out of there. And I'm sure it's on one of the slides I've given you as well. Now, why do we want to do it in this particular case here? So what we are trying to do by refluxing is we're trying to get a complete reaction. So we're heating it up, we're speeding it up, so we're wanting to turn all of the ethanol into a carboxylic acid of ethanoic acid. I'm not going to put the hydrogens in. So what we're trying to do is we're trying to do this reaction here. And so we're oxidizing, and then anything that has not finished oxidizing continues to be reacted by condensing and falling back in until hopefully we have got only this product there. We're making a lot of this as quick as we can. Right, let's look at distillation. So why would we want to use distillation when reflux works so well to make our ethanoic acid? Right, so let's do the same thing here as well. Let's start by saying why we would use it. So distillation is used to separate substances based on their boiling points. And then, I'm just going to put BPT in here, and then we would say how it works. So let's just go back through how it works. So we put our substances in here again. So this time we've got our ethanol and we've got our dichromate, and we heat it up again. Right, but this time we've turned the condenser around this way, and we've got the option of setting the temperature. So we're going to set that temperature just around about the boiling point of the substance that we want to isolate. So in this case, what we're trying to do here is we're trying to, instead of reacting all of that ethanol and turning it straight into the carboxylic acid, we recognize that actually the first step in this reaction oxidizes it partially to a aldehyde. And if we reflux it, that aldehyde would keep reacting and turn into the carboxylic acid. But let's just say, for instance, we wanted this and not this. To get this out, we need to distill. So we would set this distillation equipment to the boiling point of the aldehyde, because the aldehyde in this situation must be the thing that we want. It's a very common use of distillation. Now, looking at this, if you want to go ahead and review your bonding or get a really good answer, you can see that this thing here will have the lowest boiling point out of ethanol, ethanol, and ethanoic acid, because it's the only one that doesn't form hydrogen bonds. Hydrogen bond former, this is a thing that can form hydrogen bonds. This has not got its O bonded to its H. So it's got the lowest boiling point. You don't need to know the boiling points, but we're going to set this temperature to reasonably low. I'm just going to go 50 degrees for this. That'll be about right. You don't need to worry about that number. So we set that temperature to 50 degrees. These two chemicals in here, the ethanol and the dichromate, react, and then they make some aldehyde. And this aldehyde boils pretty quick because it's got the lowest boiling point. The gas comes up here, comes through this tube, and when it hits this tube, with all the water going in and out, it cools down and the gas turns back into a liquid. And because it's sloping down this way, that liquid drips into this container and we separate it and collect it here. So in the second part of this, I have combined the why and the how. So we're separating the aldehyde. So this is going to be a reasonably common question, and it's going to be an excellence question. Okay, this too is going to be a reasonably common question. We've got the darn chemists who can't quite get labels that stay on their bottles, or they're pretty crap at labelling their bottles. So, I've seen a... Oh, I love this. I think that's supposed to be a 4. So 4 bottles, each containing a different colourless liquid, have been incorrectly labelled. And here are the 4 liquids. And we have to develop a procedure, should say a valid procedure, to identify each of the 4 liquids. So I always like to develop the procedure separately and then go back and do all these bits and pieces here. So that's what we're going to do right now. So what we need to do with our procedure is we need to figure out some reagents that will have different observations for these. So ketone, nothing. Ketones react with nothing. Alcohols, we know they can be oxidized, and oxidants have color changes. So we're looking at dichromate, which is going to be orange to green. We're looking at permanganate, which is going to be purple to colorless. We could use, nope, that's the best too. Propanoyl chloride, that's a fabulous one to have. We're going to react that with water because it's acyl chlorides are the only things that have violent reactions with water. And propanamine, amines, not amides, are basic. So look at all these things we've got here. So what I'm going to do is, if I have an acyl chloride, I always start with water. So I'm going to do that first. This is quite an easy one here. It's going to give it some litmus paper or some universal indicator. Then to distinguish between these two, I'm going to pick one of these. I'm just going to pick the permanganate this time. And then I'm going to identify this one by process of elimination. So we're always going to start with this sentence. To a sample of all 4. And pick the one thing I'm going to add first. Okay, so if I'm going to add water. And then what I need to say is what I would see to distinguish some of these from each other. So I'm going to say my positive observation in one beaker or test tube, whatever you've used, I will see a violent bubbling and white fumes. And that will tell me, hold on, fumes, that will tell me that I have got the acyl chloride. And then I should say my negative observations, sorry. So let's just get a red, poor old red. So my negative observations is in the other three, I see no bubbles. That'll do. No bubbles or fumes. You don't have to see what, you just have to say how it looks different to the others. There's no bubbles and no fumes. So I've successfully got the acyl chloride out now. So now I go into my step 2 to a sample of the remaining 3. And I'm going to pick my second, the remaining 3. Oops. Remaining 3. Wish I'd bought a paper copy of this test time. I'm going to add universal indicator. Okay, and in one sample, this is my positive observation. I'm going to get the universal indicator is going to turn blue. And in the other 3, which is my negative, it's going to stay green. Okay, so the blue one is going to identify the amine, which in this case is propanamine. Right, so now I've got 2 left. So to a sample of the remaining 2. And the second to last thing I picked was my permanganate, potassium permanganate, K, capital M, little n, capital O, 4. I'm going to acidify that. And guess what? I'm going to add heat. And I should see 1 goes from purple to colourless. And that is going to be my alcohol. Sorry, this is just annoying me so much. But I'm going to, oh, look at that. And then my negative observation is that the purple stays purple. And that must be my ketone. So now I've got all 4 identified. So that's a long way to answering the question. But what I haven't done yet is done all these. Have I done the observations linked to the species? I probably have. I should have, I could, if I'm really worried about the linking, I can put only acyl chlorides bubble with water. Amines are basic, so they turn universal indicator blue. Alcohols are able to be oxidized by permanganate. Type of reaction occurring, I can just go back and write that in here. This is a substitution or a hydrolysis, which is a subset. This one's an acid-base reaction, and this one's an oxidation. So that's now done. And it wants a chemical equation showing the structural formula of the products. So what this usually means is that you don't need any byproducts. This one's the trickiest one here. It's an acid-base reaction with a proton donation to water. Go and look at the answer schedule to see those reactions, because you can tell that if I do it, it's going to be ugly, very ugly. There you go. That's the end of the test. So hopefully that can help you if you're having trouble with it, along with the mark schedule for that test, which will be on the Google Classroom. And if you've got any more questions, you are going to need to make an appointment to come and see me once we're back at school, or through the Google Classroom if we stay in lockdown. Hope you're having a grand day, everyone. I'll see you soon.